Okay, so moving on to that next example, number 3. So here I have the square root of 3 minus 2x minus the square root of 1 minus 3x, and that equals 0. So remember, the first rule is to always isolate the radical. Well, what you'll notice is we have both two sets of radicals. So what you actually really want to do is you want to isolate one on one side and one on the other. So what I'm going to do is I'm going to add the square root of 1 minus 3x to both sides. And so I end up with 3 minus 2x equals the square root of 1 minus 3x. Okay, so now I am going to square both sides. And when I do that, I get 3 minus 2x equals 1 minus 3x. So this one is actually one of the simpler ones, which is kind of nice. So I'm going to move variables to one side, constants to the other. So I'm going to go ahead and move that 1 there, add the 2x to the right. And so I end up with 2 equals what? Negative 1x. So then I'm going to divide both sides by negative 1. So negative 2 equals x. Well, we need to check it, and we need to see if it's correct. So again, whenever you check it, you go back to the original radical, okay, original problem, before you even got started with any kind of movement. So now what I'm going to do is I'm going to go ahead and, I'm going to substitute that negative 2 in for x, and we'll see whether added together or subtracted together it equals 0. So now I've got 3 actually plus 4, because negative 2 times negative 2 is going to be 4, minus 1 plus 6, the square root of 1 plus 6, I should say. So then here I have the square root of 7 minus the square root of 7 equals 0. That is true, because the square root of 7 minus the square root of 7 is going to be 0. That does equal 0, so therefore this is a solution. And again, if this was not a true statement and negative 2 was your only option, you would just say that there is no solution. Okay? So now what I want to do is I want to look at a couple of ACT problems that work with this. So number 4 here, this is an ACT type of problem that I have the square root of x minus 1 is greater than 5. So the square root, the radical, is isolated, so that means I'm going to square both sides. And I get x minus 1 is greater than 25. I'm going to go ahead and add 1 to both sides, and I get x is greater than 26. So then I need to check it. Okay, so if I have the square root of 26 minus 1, I need to know whether that's greater than 5. Okay, so when I do 26 minus 1, I end up getting 25, the square root of 25. So then, with that, I get the square root of 25 is 5. Now here's the catch. 5 is not greater than 5. 5 is greater than or equal to 5, or 5 is equal to 5. However, what we need to note is this does say it's greater than 26, not greater than or equal to. So actually, I wouldn't want to put 26 in here, because that's not true. There's not an equal sign. And a lot of times whenever we go in to check, we want to go ahead and just use the number that we got. However, there's no equal sign. So really what I want to do with this type of problem is I want to choose a number that's greater than 26. So let's just say 30. 30 minus 1. So the square root of 30 minus 1 is the square root of 29. When I actually take the square root of 29, I get this crazy decimal, 5.385, and it just keeps going. Okay? So because of that, because that number truly is greater than 5, this statement is true, because a number that's greater than 26 would end up being correct when substituting it in. So that's the big thing to be careful of, is, especially on the ACT, is that if it's not an equal sign, what you really need to do with that. Let's look at example number 5. So I have 1 over the cube root of x squared minus 2, and that equals 5. So This truly is the radical is isolated. It's just in fraction form. So I'm going to go ahead and cube both sides. So I give that cube to the 1, and I give it to this cube root. Well, 1 cubed is still just 1. The cube of a cube root is whatever's inside, so I have x squared minus 2. And 5 cubed is 125. So now what I'm going to need to do is I'm going to need to multiply both sides by the denominator, which is x squared minus 2. So I get 1 equals, and I need to distribute. So I get 125x squared minus 250. So what I'm going to do is I'm going to go ahead and move this 250 over so that way I can work on getting that x squared alone. So I'm going to bring this up here. I have 251, and that equals 125x squared. Oops, can't quite see that. And then I'm going to divide both sides by 125. And so now I have 251 over 125, and that equals x squared. So I'm going to need to take the square root of both sides. And now truly, because this is an ACT problem, the answer choices are going to be in a decimal form. So when I go ahead and do that, I get 1.417, which would be that decimal answer for that. Okay, now I just have one more that's again like an ACT question. So I have the quantity of x plus y cubed equals 64. And the square root of x minus y equals 4. And so we want to know, what does x equal? Okay, so this is an ACT type question. So really what's going to happen is I'm going to treat these two separately and try to get them into like an x plus y form. So I'm going to kind of label this 1 and 2. So this first one that I have x plus y cubed equals 64. So to undo that cube, I'm going to have to take the cube root. And so now I get x plus y equals 4. Okay, so at this point, that's where I got to keep it for just a moment. And then here for this second one, I have the square root of x minus y, and that equals 4. So I'm going to need to square both sides. So when I square both sides, I get x minus y equals 16. Okay, so now I'm at this point where I have two equations that I can actually use solving by elimination, solving by substitution, but basically I'm solving a system of equations. So now I have x plus y equals 4 and x minus y equals 16. That's what I got from the 2 after I, had to do a little bit of math manipulation. And I'm going to go ahead and solve by elimination and add these together. The y's will end up adding to be 0. The x's, I get 2x equals 4 plus 16 is 10. I lied. It's not 10. It's 20. I'm a step ahead already in my brain. And now I'm going to divide both sides by 2. And then I get x equals 10. Now, in this case, you could go back and check just to make sure. So if you went back, remember our originals was x plus y cubed equals 64, and the square root of x minus y equals 4. So those were our originals. Now, truly, the ACT, remember, only asked what does x equal. So we really only had to find x. We didn't actually need to find y. I could go back and substitute to find out what y was and to check it and such. But a lot of times you can kind of assume, I hate to say that, but on the ACT, because of the answer choices, if they're just looking for x and you go about solving it, there's probably not going to be an extraneous solution. And for sake of time, it's probably best not to necessarily check. However, if you had a problem like 1 through 3 that we saw in the videos today, that you always do want to check, because sometimes that can be the tricky part, especially like something like number 2 where you had 2 solutions but only one of them worked. That's the type of thing that you'd end up seeing on the ACT.